Hi, I'm Heidi, and I'm here with Neil today to talk with you about some new things that we've done, some new capability, new instances that we've brought together over the recent months here. We have a very deep and large set of instance choices available for our customers. Getting close to 500, we're well over 400 different instance types. And really, what we've done over the years is we've tried to make sure that we have the right hardware for your needs that fit the workloads that you run. So whether you need memory intensive instances or you having compute intensive workloads, you need a lot of storage or fast access to storage, or you need accelerators like NVIDIA GPUs. We have different instances for those workloads. As an example, we have several different instance types that work for HPC workloads. We have compute and memory and networking capability for your HPC workloads, your high performance computing. And one of the things that we offer is a collection of different processor types. As we go through the presentation today, you'll see some blue boxes on some of these slides, and those include links for some more information in case you want to learn more. The majority of our instances are Intel-based instances. We use a lot of Xeon processors in our instances, and one of the more recent ones that we launched is the C6i. This instance is based on Ice Lake from Intel, and we have different offerings there, whether you need 4 gigabytes, 8 gigabytes, or 16 gigabytes per core. You have different flavors of instances at your disposal. So in addition to Intel-based instances, we also offer a selection of AMD-based instances. And this gives us the ability to deliver broader support to more workloads. There are a set of instances that are good for service nodes, compile time, that sort of thing. But one of the instances that released last January, a month ago, is something that a lot of people have been interested in, and that's our HPC 6a. To dive in a little bit more about that, the first thing about it is these instances, or the HPC 6a, is designed to handle MPI jobs or tightly coupled workloads. These workloads or jobs that need to run across a large number of nodes, where MPI ranks need to communicate both within a node and across nodes. Because of that, we need to have the nodes close together. And so these instance types are available within a single availability zone. We need a high-speed network and a high-performance file system. So for this, we have a 100 gigabits per second network, which has low latency and high bandwidth, and it allows us to have MPI ranks communicating efficiently across the cores and allows us to scale better. So the Milan processor has 3.6 gigahertz all-core turbo frequency, 48 physical cores per socket, or 96 per instance. These are physical cores, so there's no simultaneous multi-threading enabled in this instance, and so a core is a core. In addition, there are 384 gigabytes of memory, or 4 gigabytes per core. And this memory includes an L3 cache, which is unified and distributed per 8 cores. In addition to the high bandwidth and low latency network, the closeness of these instances, these workloads typically don't need redundancy, they need scale. That's more important. And so that's one of the reasons we were able to look at offering a price of 3 cents per core hour, or 1.6 cents if you have a savings plan, if you commit and reserve instances. The 1.6 cents per core hour really gives you the ability to run these large scale jobs across tens of thousands of cores at a price performance that is reasonable for these HPC workloads. These workloads typically don't need the high bandwidth to get to the internet or outside of the cluster. And so again, finding these ways to optimize these instances or these nodes for us gives us the ability to reduce cost. With that, we'd like to take a look at some performance of some real HPC codes. And so I'd like to turn it over to Neil.
Great. Thanks, Heidi. Yeah, so I think when it comes to such a broad and deep set of instances, there's always the challenge of what is the right instance for what you need to do. And often the answer is that there is never one that is suitable for everything, but we give a broad selection so you can decide. But we thought it would be useful to at least highlight probably the 3 main instances that we see customers use. So the C5N, all of these are in the largest of the instance options. So a C5N 18X large, that's an Intel Skylake, and then the C6i, the Ice Lake, and then the 6A that Heidi was just describing, the AMD Milan. And these are, weather applications, which is a very popular workload that people run on AWS, one where you need lots of compute to do it. And if you look at these examples for WRF and for MPAS, it's a pretty clear that as you scale out with the instances, then the 6A having the superior memory bandwidth, most of these codes are memory bandwidth bound, actually gives you a much better performance. And that stays true until you essentially reach the end of scaling for the code. And that's true also for MPAS. So you kind of see an example of the progression, because these are actually, interestingly, time-wise, C5M was the earliest. These are all EFA-enabled instances, and 6A is the latest one. So in some ways, pushing out the boundaries, and for weather customers, certainly 6A is an attractive option. But if you go to the next slide, I think probably this adds the extra dimension, which is the cost example. Now, this is the on-demand cost. Anyone who is using AWS knows that there are a range of different pricing options. On-demand being no commitment, obviously it can go cheaper again with a 1 or 3 year commitment through savings plans or reserved instances. But what we're seeing here is if you now take that first graph and plot it cost per simulation against the number of instances, then you see that the C5N and the C6i is a really good Intel instance and choice for customers, because you can see that it gives a higher performance than C5N. Right. When you look at the 6A, as Heidi was saying, which has really been price optimized as well, then you see you get the superior performance, but also a significantly lower cost for no commitment. So it's a really attractive offer, basically, for weather customers, and we have many of them using it today, actually. But weather's just one. Weather and climate is just one sort of workload that we see people use. If you go to the next slide, then codes like GROMACS, computational chemistry is another really popular one. And so you see for two different types of simulations here, again, the similar chart looking at the performance as you go across these kind of 3 core instances. As you see the difference between the left and the right, it does depend a little bit sometimes on the case-by-case situation. And so most customers actually, the first thing they do is they do benchmark similar to this. I want to test the Ice Lake, I want to take 6A, and I want to compare, how they perform it. And some ones, they're pretty close together. Another one, then the extra bandwidth sometimes can really, take it away. Now, the next slide, and the reason we're going through these different workloads is we know that there's not one HPC customer. There's many, many different people and personas and workloads. And one that's kind of dear to my heart is computational fluid dynamics. And so you're seeing here 2 different models. And I think the one on the left is a smaller model with StarCCM, quite popular code. And ANSYS Fluent is one on the right, which is actually a larger model case. Similar to the previous ones, you are seeing this clear trend from the earlier Intel C5N towards, the 6A. But now you're actually seeing, I suppose, the Ice Lake and the 6A being a little bit closer together. But still, and we haven't repeated it for the sake of it, if you factor in the cost now, certainly 6A does give you a very attractive option. So I think back over to you, Heidi.
All right. Okay, so moving on, we talked a little bit about Intel and AMD processors, and now let's talk about ARM. So one of the instance types that AWS offers is their Graviton family, their Graviton-based instances, and these are ARM processors. And we have several choices here. We've got compute-intensive workload choices, and we've got storage-intensive workload choices. And we'll talk a little bit more about our 3rd generation in a couple of minutes here. As far as storage optimized instances goes, one of the things that we were able to do is to add SSDs to these particular Graviton-based instances. And what this does is this allows users who need the closest possible storage for I/O to see lower latency and higher performance. So these are good for workloads that have databases or that do streaming or search engines or maybe have a distributed file system. Another thing that we added recently is we added GPUs to our ARM processors, to our Graviton 2 based instances. This was something that we wanted to do for specifically an example is Android game developers, so that they could test and run their codes to make sure that they ran on ARM, their games so that they ran on ARM. So it offers a cost-effective approach to being able to do this with the NVIDIA T4G Tensor Core GPUs. So next, we have recently announced the third generation Graviton processor, the Graviton 3. This is a chiplet design-based processor that has a lot of new beefy capability over the Graviton 2. We went from 30 billion transistors all the way up to approximately 55 billion transistors with Graviton 3. And you'll see that with higher performance. We'll talk a little bit about what kinds of things are in this chip so that, to drive more performance. But I also wanted to mention that this is our very first DDR5 offering that we have in our data centers, and that's going to be giving us better bandwidth to memory. So this particular instance has 64 physical cores. It again has no simultaneous multi-threading, so that the resource capability, all the resources can be delivered directly to the cores. It is a single NUMA domain here, so that there is no near and far memory choices on this particular chip. The cores are connected with the network on chip, which is a mesh, connecting the cores together that drives more than 2 terabytes per second bisection bandwidth. And the L3 cache is distributed across this mesh so that it is evenly accessible to the cores. This particular chip has 300 gigabytes per second of theoretical max memory bandwidth, and it is quite straightforward to be able to write simple loops and not have to use special instructions, standing on your head to achieve 80% of that bandwidth. So one of the things that we've seen is the capability, the potential capability of this chip has really been fascinating. The last thing I want to mention is the 8 memory controllers, the DDR5 4800 memory controllers that of course have encrypted memory. Just to show you a little bit of a difference between the Graviton 2 and Graviton 3, before we look at some performance numbers, I wanted to show you, you can see that whether it's from a wider front end to more enhanced prefetching capability to a larger instruction window, it has more capability. One of the things I wanted to mention is the 256-bit SIMD SVE instructions. So SVE stands for Scalar Vector Enhancements, and it's a complementary set of instructions. It is primarily designed for HPC and ML workloads, and it allows you to pack more data per instruction, so you can actually work on larger data sets per instruction and deliver better performance. So to give you a feel for this, tightly coupled workloads, HPC workloads typically use MPI for communication between processes. It gives you scalability across processes for better time to solution and being able to solve larger problems. And then you have OpenMP, which gives you thread level parallelism within a process. And then the vectorization that can be achieved with instructions like SVE instructions gives you fine-grained parallelism within a thread. So we have these different tiers of parallelism to give you the best performance possible on these architectures. And with that, let's take a look, Neil, at some of the performance we're seeing.
Yeah, so this is still in preview mode. So there's still, I think these are still early results in some ways, and we're working with quite a few customers on doing further testing. But we do have some examples here of the kind of single node test where you can see that for those sort of codes that we showed before, GrowMax, LAMP, Swarf, you're seeing around a 50% jump in performance compared to the previous generation of Graviton 2, which is a really big shift. If you look at, other generations of chips and go from one to the other, that really is a big jump in performance. If you go to the next slide, if we now go from looking at just the Graviton 2 to Graviton 3, let's have a look at just one of those code lamps and bring in actually some of the other instances. And these are normalized to the C5N result, the Intel Skylake. And what you can see is for this code, if you go to the C6G, which was the Graviton 2, the blue, again, you see that big jump, on the green bar going to Graviton 3, but it actually it's very competitive. It's slightly faster than the Intel Ice Lake C6i, slightly slower than the 6A. Again, if you look around the memory bandwidth numbers, it's kind of explained by that a little bit, but it really does show you how competitive it is. Now, at the time of recording, again, this is still in preview mode, and so the pricing is not available on the website for me to be able to show you. But if you look at the C6G price performance, it's always been extremely strong. And so I think once we get a bit closer to the release time and we start bringing out those comparisons, I think you'll find Graviton 3 that continues to be an extremely good option for getting the best possible price performance. So if you go to the next slide, I suppose this is the one what I was talking about in terms of helping customers to do some of this early benchmarking. And one of the great things is, I just showed single node performance. We actually have done some tests with Formula One for their full car simulations on many nodes. And what they're seeing is, again, a consistent story that Graviton 3 is about 40% faster. So from really micro benchmarks to single node to full applications, it's looking like a really promising instance. And I hope when it comes out later this year, people can jump on and have a go. So with that, maybe back over to you, Heidi.
Yeah, well, actually, we're just going to wrap up, and I hope that you got an insight into some of the things that we've been doing over this past year. And there are, again, links to more information if you're interested, and hope you have a nice day. Thanks for joining.
Thanks.